subsequence given two strings text1 and text2 return the length of their longest common subsequence. Yeah, if there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters can be deleted without changing the relative order of the remaining characters. For example, ace is a subsequence of A, B, C, D, E. A common subsequence of two strings is a subsequence that is common to both strings. So, for example, one we have string one, which is A, B, C, D, E, and A, B, and text two, which is A, C, E. We have three because it says the longest subsequence is A, C, E. So we have A here and C and E inside there. So that's why we have three. Here, text one and text two are both the same. So we have three because there's exactly three in both. So the longest common subsequence is ABC, and its length is 3. Example 3, we have text 1, which is ABC, and text 2, which is DEF. The output is 0 because there are no common subsequence. There's none here that matches here. So let's get into this. So this is a dynamic programming question. Dynamic programming. So let's name m and n equals to, let's make m length of text 1 and n length of text 2. So let's make our dynamic. Let's make our table to start the length of the longest. So let me copy and paste this so we can keep track of it. This little lengths. Let's call it dp equals to, let's make our list and give it, make 0 as our first every and then let's make multiply by n times n minus, hold on, n plus 1, yes, n plus 1. And to go ahead and do this, let's make this in parentheses, and then for every letter in the range of m plus 1, yes, m plus 1. So now this will be our row and our columns. So let's go ahead. So our rows and column. Let's go ahead and let's now for I in range of let's start from 1 to m plus 1, and for j in the range of also 1 n plus 1. So if we have if text 1 I minus 1 is the same as text 2 I minus, hold on, no, j minus 1 dp ij will be equals to the current dp that we are on will be equals to I no it will be equals to dp I minus 1 and j minus 1 plus 1. Else if not, let's take the maximum. It's dp I j will be max, no oops, j will be equals to the maximum of d hold on, dp I minus 1 j or dp I and then j minus 1. So this basically will take for every so it's basically going to make a 2D grade. So every grade will start with a 0 in all of them, and then we're going to go through from 1 all the way to the number of, in this case, letters. For text 1 here, and then let's say we get to this. In this example, we're going to go to this, and then check text if this matches with this, which it does in this case, then this one will apply. And then if we move on to this for j, and then this doesn't match up with this, it will come here. And also for this one, and then this one also doesn't match up with a, so it also does this. And then we move on to the next which is b, and it's gonna come to this, doesn't match up with this, doesn't match with this, and then move on out to c. And c doesn't match up with this, so we come here, and this one it doesn't match up with c here, so we come to here, and then c doesn't match up with e, and so on until we get to the end of it. So return hold on, return m, hold on, dp m n, and that's it. I think so. Let's see if there's any syntax errors. If text is not defined, text 2. dpi minus 1 so this indices does not do what? Must be integers or slices. So dp I minus 1 j. Oh yes. That's it. And that's it for this problem, and it's been solved, accepted. So we've been able to pass these 3 cases, and the time and space complexity for this is and space complexity is O of n times n. Let's submit to see if it's going to pass all cases. And it's been able to pass all cases. And that's it for this problem.